Here is my fourth DER of my grade 11 year, Project 2.4.1, Breadboard ATmega328P. The Breadboard ATmega328P is a project that consists of three main builds: the ATmega328P IC chip itself, the 5-volt voltage regulator, and my environmental sensor, input and output. To begin, I will discuss the ATmega328P IC chip, the same IC chip that can be found in the Arduino Uno. To wire up the ATmega328P, first pins 8 and 22 are wired to ground, followed by pins 7 and 20 to VCC or power. Next, the reset pin is wired to a PBNO, which is then wired to ground. Finally, a clock signal is created using a 16 MHz clock crystal wired to pins 9 and 10, along with two 20 picofarad capacitors getting wired to pins 9 and ground and 10 in ground. The clock crystal and capacitors are in place with the role of creating an external clock signal to be used later on for timing purposes within the circuit. The second part of the circuit is the voltage regulator, which also plays a huge role in this build, allowing for it to be compatible with 7 to 12 volts. This mini circuit can be built using a simple 7805 CT voltage regulator and two capacitors. The circuit diagram is on screen. The third and final part of this build is my personal environmental input, being an infrared sensor, and output being a bar graph and a standalone yellow LED. The main component in this build, being a PIR sensor, is an advanced sensor built using two different main components: the pyroelectric sensor and the cover of the sensor, which is the Fresnel lens. The pyroelectric sensor generates energy when exposed to heat. For example, when the human body passes by the range of the sensor will detect the movement and output a high through its output pin. This is because humans emit heat through passive radiation in a form of infrared radiation. This is where the name PIR, or passive infrared, comes from. The passive represents the fact that the component does not use any energy for detecting purposes. The second part of the module is the Fresnel lens, which is specifically created to angle the infrared light towards the pyroelectric sensor. This allows for a larger monitoring range, not just one directly in front of the sensor. Once motion is sensed and a high is emitted to the ATmega328P's digital pin 5, bit shifting occurs as the function type voids shift out, creating a booting up effect on the bar graph with the help of the 595 shift register. Following this sequence, the yellow LED is turned on and once again bit shifting commences, this time opposite to the original display on the bar graph. The only exception being the delay, which is equal to the resistance of the pot multiplied by 1,000 to allow for a feasible time. After the bit shifting finally concludes, the yellow LED is turned off and the motion sensor's job is complete.